Hello everyone and welcome to another explanatory video on African Tech Gurus. This is our #1 technology channel where we actually learn technology and coding by actually doing it. So today we're going to cover pointers and array. Please do pay attention on this one because it's a bit complex and it requires your utmost attention. But if you're not also able to pay attention for long periods of time, it's okay. Just pause the video when you need a breather, just rewind. Even if you want to explore more content and more concepts, just feel free to go out and seek other material. So you can Google, you can YouTube, other material, as long as at the end of the day, make sure you fully understand today's concepts. So what is a pointer? So basically a pointer is just another variable which will contain the memory address of, let's say, another variable or variables. So at the end of the day, remember a variable is a memory location in the computer or in your PC or whichever electronic device. So it's a memory location and it's a variable, and a variable is a type of memory that can change the content that it has because it's not fixed. So that's why it's a variable. A variable means it can change. So here, a pointer is a variable which will contain the memory address of anything else. I hope you got that. So it just helps us have the address of any other type of data that we want to have, or we want to know where it's stored in the computer's memory. So it's as simple as that. Yeah. So there are different types of data, and they also have different types of sizes. So now, depending on the type of the variable, now the computer will have a different set of the number of bytes that it will have. So for example, a character, which is anything, letter A is a character, N is a character, any single element is a character. So it will have 1 byte. And an integer is any number that does not have a decimal point. It will have 4 bytes, and a float will also have 4 bytes. So depending on the computer that you're using or the machine that you're using, it will might these types of variables with different sizes. But for most 64 Linux machines, this is how you get to know. So if you want to get to know the size of variables that your computer is able to store, you can determine that using this code that they have given us over here, this one. So what it will do is it will get the size of your character, of your integer, of your float on your computer. So don't be surprised if yours is different if it is not a 64-bit machine. So the other thing is the size of a type will determine how many different possible values a variable of this type can hold. So for example, if you're to look at the character, we say the character can hold 1 byte. So remember, 1 byte is equivalent to 8 bits. So at the end of the day, our computers are binary system computers, so that means it can either store 0 or 1. So that means it can only store the different information that we want to store in either a 0 or a 1. So those are only 2 options. And remember, out of these 2 options, we have 1 byte of which you can store it, and this 1 byte has 8 bits. So in short, what we're saying is in our memory space, we have 8 slots per se, and each of these 8 slots can either have a 0 or a 1. So at the end of the day, we have 256 possibilities. So what that means is 2, which is the zeros and ones, how the information can be stored, times or to the power of 8, which 8 is the number of spaces that we have, which is 8 bits, bits, B-I-T-S, or 1 byte. So at the end of the day, we can hold 256 different values. So that will be from negative 128 to 127. So those are exactly 256. So for an integer, it's different because it has 4 bytes. So what that translates to is 32 bits. So now we know we have 32 bits, which are like 32 small, very tiny memory locations in space in the computer's memory. So all of these 32 memory locations, they can either have zeros or ones. So that will translate to it can hold 2 to the power of 32. So that is the different possibilities that an integer can hold. So when we are declaring a variable, the computer will definitely reserve the right amount of space available for that variable in memory, and it will do this depending on the type. So if you have an integer, 4 bytes; if you have a float, 4 bytes; if you have a character, 1 byte. So it will get to do that. And the space is reserved for the variable is its address. So there's also that the space reserved for the variable is its address. And when you assign a value to this variable, the computer will store this value at its address. I hope you got that one, but we're going to go over it right now. So basically what they're saying here is when we have a variable that we want to store, let's say here they've given us an example of character C. C is a character because it's one single element. C itself, it's a character. So it will be stored in the memory. So what they're saying is the space reserved for this variable is its address. So think of it as a house. If a house is built on a particular space or a particular land where it is built, that is its address. So here it's the same concept. When we declare a variable, the computer will reserve just the right amount of space for this variable in memory depending on its type. So here C has been placed at address 8. But remember, we have not given C any value. So in short, we have just declared that variable, but we have not initialized it. So that is the same as saying, I've opened my notepad so that you're able to see character C. That's simple. There you just declared it, and wherever you have declared it, it will be stored in memory, and it will have an address where if someone wants to get to know where is this C stored, they are able to see it. So here it's been stored in the computer at address 8. I hope you got that one. Yeah. So actually I think we've done that over here. So in this example, they're saying we have declared a variable C of type character and the address is 8. So at this stage, the only thing we've done is we have not assigned a value to it, to this variable. So we don't know what it contains inside it. We just know that it's a character, and we don't know what it contains. So the next thing is we can assign a value to it, which will be initializing it. So we've declared it, so the next thing we want to do is initialize. So this is the next step here. This will be initializing. So this character C, which C is the variable name stored in address 8, should contain character H or the value H. But remember, our computers can only store numbers, so it won't actually store the value H. It will store its ASCII code for H. And if you don't know about this, quickly pause the video and look up the ASCII table so that you're able to be familiar with it. And the ASCII code for H is 72. So it will be 72. And C will contain 72, which is the ASCII code for H. I hope you got that one. So the other thing we can do is we can also store integer variables. So remember, integers take up 4 bytes. 4 bytes. So here they have broken down the addresses and the variables into into a byte each. BYTE, not bits. So remember, each single byte, for example 20, within it will have 8 bits, because 1 byte is equivalent to 8 bits. So here we are declaring an integer n and initializing it to have 98. So that is the same thing that you're doing here. The first thing that will happen is it will create a memory location called n, and it will have an address. So this address will span all the way from 26 to 29. But for the purposes of knowing the address, we pick the smallest one. So 26, or where that variable is starting from, that will be the address of this specific variable. So if it's taking up 100 bytes, the lowest value of that address will be the address of that variable. So here, n is an integer, it's taken up 4 bytes as you expected, and it will contain 98, which is the value. So now we want to look at something else. We don't have any control on where the variable will be stored. That is entirely up to the computer. So in order for us to know where it is stored in memory, we can use the address of unary operator, which is the ampersand sign. So we're going to look at that right now, because we won't know where our variables are located. We just have to ask the computer to help us know, and how we do that is we use the ampersand sign, this one, or the and sign for some people, and in this case it is the address of unary operator. Yeah. So now we do have an example here. So here we have we have declared character C and integer n, and we want to know where these two are stored in memory. So how we do that using the address of unary operator is we can use printf, and what we'll have is the address of variable C is percentage p. This is a placeholder for a pointer, and what you're going to have here, as you can see, is whatever value will be found or collected by the address of unary operator for C will be placed here. So at the end of the day, this is what we will have. The address of variable C is at this address, and the same for the integer n. So as you can see, we have used this percentage p to print the address, which is the value of the pointer, and here we've used printf to actually get that. So what this does is it just simply gives us the address of that specific variable that we are looking for. So it can be any variable that you have. This is just how you can get the address using printf. So I hope you got that one right. So now I want us to move to the next thing, which is how do we store the memory addresses. This one is a bit more complex, but you can just pause, you don't have to worry, but just make sure you take it one step at a time. So now I want us to look at how do we actually store the address that we have now known how to find in a variable, and this variable will be a pointer. So at the end of the day, a pointer is just that piece of variable that will store the address of that piece of data. I hope you got that one. A pointer is a variable. This is what I'm looking at. It's a variable that will store the address of a piece of data. It's that simple. So what a pointer does, it's simply the address of a piece of data in memory. That's that. A pointer is just, if we can call it a road sign, it's just a road sign. It just tells you it's headed. You can find whatever you're looking for in this address, more or less. So a pointer is also a variable. Remember, each and every single data that we have, no matter how simple, is stored in the memory of the computer. So it also needs to be stored, and a pointer is also a variable. So a pointer variable is a variable that will store the address of any piece of data that you have. And just like any other variable that we have looked at, it also needs to be declared. So it also has its own syntax, and that syntax is this. So what this does is we need to know the type of that pointer, or where is that pointer pointing to? What type of data is it pointing to? Is it pointing to a character? Is it pointing to an integer? Is it pointing to a string? We need to know what it is pointing to. We really don't know by now exactly what is contained in it. We just need to know its type. That's it. And the next thing is we have the asterisk and the name of the pointer. So this asterisk, what it tells us is this variable, which is the pointer now, is a pointer. So without the asterisk, it's just any other normal variable. But now with the asterisk, we now get to know that this specific variable that we are creating is a pointer, because we have seen that a pointer is also a variable. So at the end of the day, we have the type that this pointer is pointing to and the pointer itself, which is that. So this is a good example. So here we have a pointer ptr, that is the name of our pointer, and it is pointing to an integer. We don't know now exactly what integer it is pointing to. We don't know if it is 100, we don't know if it is 102, we don't know if it is 42, but we know that it is pointing to a integer. I hope you got that one right. Another example that we can do if we want to look further at it, this is it. So here ptr2 is a pointer to a character, because now this tells us what it is pointing to, the type of data that it is pointing to. So here we know that our ptr2 is a pointer pointing to a character. It is that simple. So don't be very stressed when you see it like this. It's just that the asterisk, which I have highlighted, just tells us that we're dealing with a pointer variable. That's it. Yes. So because a pointer is like any other variable, remember it is a variable. The computer will also give it memory as well. It will give it some space in memory for it to store whatever it needs to store, whatever address it needs to store. And on most 64-bit machines or Linux machines, it will have a standard of 8 bytes. So what that means is 8 spaces in memory. So this is a very good example. Here we are declaring a variable p, and this variable is a pointer variable, as we have seen here, and it's pointing to an integer, and we don't know what integer it's pointing to, but it will have 8 memory spaces for this pointer. So 51, 52, 50, 51, 52, 53, 54, 55, 56, 57. Those are 8 memory locations for the pointer. So to get the address where a pointer is stored, you can use the same technique that we used above for the address of unary operator, and you can just use the ampersand sign. So that will give you the address of that pointer. So here, for example, the address of pointer p, it's 50, because 50 is the lowest. So it's the same thing we have done here as earlier. So we won't see 50 here exactly, because it depends on your computer, and this value will differ from a computer to another computer. So the next thing I want us to do is, let's store the address of a variable to a pointer. So here we are declaring a integer n, and we are declaring a pointer p, which will point to an integer. And the next thing we're doing is we are initializing n, we've just declared it. We've just told the computer, for now, just create space in memory called n, and we don't know what you're going to put there yet. But then now what this is doing is we're saying, okay, now that you created the memory space n, let us have 98 inside it. That's as simple as it is. And remember, an integer will have 4 bytes. So here we have n, variable n, which has 4 spaces, 26, 27, 28, 29. And in this variable, the value that is stored in it is 98. It's that simple. And then now the next thing we need to do here, we've declared the pointer p. We've declared pointer p, and it's pointing to an integer. So n is an integer. So here in this case, if we want to get the address of n, which is what you're going to do here, we need to say specifically that this pointer is pointing to an integer, and this is what that does. And here we are using the unary address of unary operator, which you have seen up. Let me just go to where it is so that you remember it. Where was it? I can't see it, but it was somewhere here. Yes, yes, here it is. The address of unary operator. This is what you're using. So simply what you're doing is we are getting the address of n. This is what it's all saying. Get the address of n. This what I have highlighted here. Get the address of n, and then once you get the address of n, assign it to p. But remember, we already created that memory location already, and that memory location is already a pointer. So here we don't need to say asterisk p, because here we've already declared it. We've already created that pointer variable, and we've already said that it's a pointer. So here we just need to use the name of the variable, which is p, and p will contain the address of n. And remember, n, what is n? N is 98. So if we come here to the visual description that they have given us, what is the address of n? It's simply 26, because that is the lowest value. So p, which is the pointer pointing to integer n, will contain 26, and that is what they have here. It is that simple. Don't overthink it, don't overcomplicate it, but it's as simple as that. I want us to look at something that they've told us here. Remember that a pointer can only point to a variable of the type it is supposed to. So this is a very good example of an incorrect example. So here we are declaring a character C and also a pointer called P, which is pointing to an integer. So this cannot happen, because what this is doing is it's getting the address of C, but C is a character, and we want to store that address to our pointer called P, which is pointing to an integer. That won't happen. It won't be possible, and if you try this, it will give you an error. So you can try out this on your PC, on your whichever environment you're using. Just try it out and see it. But for now, I'd like to leave it there. In the next one, I will try and do dereferencing, but just make sure for now you have understood how to get the address, as they had done here, how to get the address. This is what I'm saying. Sorry for that. I want us to get the address. Just make sure you understand how to get the address and how to declare a pointer and how to store the address of a variable in a pointer. I hope that's good enough for today, and until next time, have a good one, continue coding, and bye.